Afternoon, everyone. Thanks for joining today's EAC webinar. My name is Jessica Mogelson. I'm the marketing coordinator here at EAC. Today we will be talking about how you can find and fix liquid or gas flow issues early in the design process with the Creo Flow Analysis Extension. We will begin today's session with an introduction of EAC. Then Jenny Wilson, our lead associate account manager, will provide us with the overview of the Creo Flow Analysis Extension. This will be followed by a product demonstration from Todd Kraft, our technical account manager, that will be taking over. This session is being recorded. Unless there are any technical difficulties, everyone will receive a replay after the webinar. Please feel free to drop questions in the chat and we will answer them after the presentation. I do see some familiar names, but for those of you who don't know who we are, I will start off with a quick introduction of EAC. At EAC, we are dedicated to help companies transform the way they design, manufacture, connect to, and service their products. We do this by offering engineering and design services such as software support, implementation, training, and product and part design. We have a range of products and services that we sell, including CAD, product lifecycle and service lifecycle management software, as well as the Form 2 desktop 3D printer. We implement the Internet of Things and augmented reality into business strategies, offer help with design and engineering projects, and offer training courses and webinars for continuous learning. We've partnered with PTC to deliver today's leading industry software, and we are especially focusing on the aspects of PTC's Creo Flow Analysis Extension. With that, I'll pass it on to Jenny to discuss how you can quickly and easily integrate analysis early and often to understand product function and performance. Jenny, take it away.
Thanks so much for the introduction, Jess. So the goal of this presentation is to really focus on Creo Flow Analysis and what it does. So Creo Flow Analysis is a CFD solution that allows designers, engineers, and analysts to simulate fluid flow issues directly with Creo. So why would someone really need a CFD tool like Creo Flow Analysis? There could be engineers that are lacking the tools and skills to perform CFD analysis. CFD requires possibly a third-party analysis tool, and that could be high-priced. CFD is very time-consuming to complete, especially in the early stage design process. And without CFD, there's an over-reliance on physical prototypes. So with Creo Flow Analysis, you can now have ease of use, embedded CAD and CFD, easy model creation, rapid simulation turnaround, and highly accurate results. Creo Flow Analysis delivers huge business value, and these are some of the business values that we see today that it's delivering. It can streamline product development and speed time to market with concurrent design and CFD. It can reduce product development costs such as prototypes, rework, scrap, etc. You can identify and resolve design flaws early in the process. You can increase product quality and performance, also increase market share and competitive differentiation. And you can also reduce aftermarket service, warranty, and repair costs by mitigating risk associated with product failure and liability. So that's a little bit about the business value that it drives with Creo Flow Analysis. So now I'll hop it over to Todd Kraft, and he's actually going to show you the demonstration here.
My agenda today is to give you a little more of an introduction, a few more slides on the capabilities, and then we'll go ahead and do a demonstration. So like Jenny said, a lot of times the reason that engineers and designers aren't doing analysis with CFD is because they just don't have the tools or the experience of doing that. And now with Creo Flow Analysis, it's much easier that anybody can do inside of Creo. So my next part here is really why would you choose Creo Flow Analysis? And number one is it's really simple to use because it's embedded inside the Creo ribbon. You have the same kind of menus, same kind of workflows that you're familiar with inside of Creo already. Okay. And it's embedded, so there's no third-party requirement here. You're not making a step file. You're going ahead and using the actual geometry inside of Creo to do that. And I'll show you today how I can make changes in Creo and have that flow right over to Creo Flow Analysis. So there's no need to change your CAD data. It's all associative. It's all up to date. And then there's templates, there's just a very efficient meshing that is part of the solution. So the analysis setup is very easy, very high quality. Also, one thing that's when people think about CFD, they think of, oh man, I'm gonna have to have, 3 million, 6 million cells to do my analysis. Well, Creo Flow Analysis reduces it usually by about half compared to some competitors. So with superior quality and still very high efficiency and accuracy. Also, it's a quick turnaround. So the run times you will find inside of Creo Flow Analysis are very short, and the mesher is integrated with the solver. So then what that means is you can look at results as soon as you click on the run button, okay? So even though it's still converging and still running, you can look at some results before the end result happens. And then you have high accuracy as well. This technology is very, very experienced, and it's been around for a while, so it has a very good track record for giving good, accurate results. So like Jenny said before, the reasons people will pick this solution, again, it's all about time to market, improving your competitive advantage, reducing repair and warranty costs, and really just improving the ability to do that upfront simulation before you build your prototypes. So the Creo Flow Analysis comes in 3 packages. One's the Creo Flow Analysis, then the Creo Flow Analysis Plus, and then the Premium. Okay, so you can look at the type of analysis abilities there in the column on the left. So you pretty much get any kind of internal and external plus heat and turbulence for the Creo Flow Analysis. Then if you add in particles, radiation, species, moving mesh, rotating meshes, those are all part of the plus. And then when you get into cavitation, multi-phase, multi-component dynamics, you're looking at the Premium. This is a very comprehensive tool. This isn't just a tool that can do just a little bit of internal pipe flow. You can do an amazing amount of capabilities and different types of analysis with the Creo Flow Analysis. So let's go ahead and do the demonstration here. I'm gonna do 3 of them. And I think at this point, since Creo Flow Analysis came out with Creo 5, and Creo 5 has been out for a while, there's a few demonstrations already floating around the web. So I wanted to select a few things that were unique, and that's my goal today. And the demonstrations I'm doing today are very simple, very basic. That does not mean that the capabilities are not much more advanced than this. So I'm gonna just kind of make it very simple and show you the workflow and how it's done. And then you can go ahead and look out in the web for more complicated examples, or also, ask your EAC salesperson, and we can go ahead and simulate your example too if you'd like to. So integration is the key. Applications, there's your flow analysis button. And now we're inside of the ribbon here. First thing I have to do is just say hit new project. And now you'll see on my Creo Flow Analysis model tree here, I have my physics, domains, boundary conditions, and results. Those are your 4 major things you're going to define when you come into this application. Okay, so here I have a simple ball, a little closure there with an internal flow analysis, the ball valve. So first thing we're going to do is go ahead and create our fluid domain. Or actually, first thing I'll do is go ahead and just well, let's do that first. Let's say create fluid domain. We're going from left to right up on top. And first thing it does it looks for the possible openings of my model. Again, this is an internal flow. I don't want that one up on top there, so I'm just going to remove that one. And I'm going to keep the one on the right and the one on the left. Okay, so I hit OK. It has my 2 other holes there. Add to simulation. What's going to happen, it's going to create this fluid domain for me. Okay, I hit the check mark, it's good. And now when I go to my model tree, this little fluid part has been created for me. Okay, so this is the fluid, or the water we're gonna simulate. That was created automatically for me, just with some regular Creo commands here, okay? So sometimes you can make the fluid domain ahead of time, which I'll show you in my next example, or you can have the system make it for you. Next is we add up our materials. Let's do water. Okay, so here's a large list of different types of materials you can choose from. I'm going to say water right there, hit OK. And then also I have to pick on physics, which just says, you know, how many different things do I want to simulate. We're going to do flow and streamline primarily. Okay, so then I'm pretty much set. Because I made the fluid domain, it automatically creates the boundary conditions for me. So I have a BC1 and a BC2 over here. So BC1, here's the different options here. We're going to go ahead and generate a specified velocity. It's going to be normal to the surface, and then I just give a flow of maybe 2 meters per second. Okay. And we also want to say release the particles because we want to see the streamlines from this. So BC2, that's going to be just regular, just atmospheric pressure. So we're just going to say it's going to be a pressure outlet. And notice how simple this is. It's a really simple interface. You're going to pick a lot of the same things for internal flow. Pressure outlet, and there's 0 pascals. Okay. And that's pretty much all I have to do for this. The rest of this is going to be in the results. I simply say generate a mesh. Okay, it's going to generate the mesh for me. I don't have to hit generate mesh ahead of time. I can click on run and it'll generate it for me. Okay, but let's just take a look at this, what it looks like. Let's turn everything off. There's our mesh. We're just going to turn it on with the fluid here and say, let's look at the grid here. And there's our mesh for us automatically. Okay, so there's what that looks like. And we'll simply turn that off now. And now let's go ahead and click on the run button here. Okay, now it's going to solve for us. And again, it's still grayed out, so it's not done yet, but we can go down here and look at streamlines, even though it's solving right now. So here, let's look at some streamlines. Let's choose the variable of total velocity here. Okay, and then I can type in some different items for animation. Let's just change that step. And let's make it a little bit easier to see, maybe like that. Okay, so then notice it's still solving up on top. Has the typical convergence, you know, has some different residuals that it has to converge on. And that's all controlled up here in the domains. If you want to look at that stuff, you can look at the cell size and all those things. But the results here is like that. Now, what I like to do as well is, this is a 3-dimensional fluid problem, and I can choose how many number of points I want. But I can also look at this in a section view too. More looking at as a 2D. And we're going to look at it. I want to look at, you could look at that plane right there. Let's just go ahead and say, again, velocity is a good one to choose in this case. We don't have a lot of other stuff happening. There's our velocity along that plane. As we move that plane along, we can see the section, what it looks like. We can also change it to the Y here, and then we can see our section there in the Y. You can also monitor points as well. I can then get an XY plot of that point if I want to as well. Okay. It's still solving. It's not too far away from being finished here, I would think. Okay. And I think the streamline, we could turn that into maybe, if I want to look at pressure, there's what pressure looks like. So you have the ability to choose temperature, conductivity, if we have electric current going through here, strain, pressure, viscosity, density, all those things are available. Okay. What I wanted to show you though here is that if I go back into Creo, let's turn my CAD bodies back on and go to results here. And if I go back to my model tree here, there it says the simulation was done. I can change my geometry. Okay, so let's go ahead and look at wireframe here. And notice the the ball valve is kind of in the middle, maybe not quite to the middle. I can go ahead and select on that and redefine that. And let's go ahead and just almost close it, okay, like right about there. Hit OK. So I made a change to my geometry, and then I can go back to CFD here and just say update my project. And it's going to say, yeah, you know, you did a bunch of stuff. Are you sure? Yeah, I want to go ahead and update my project. Wants to make sure my holes are in the same spots. And then it's going to go ahead and mesh it automatically down the bottom. So that's going to happen automatically. And then I can go ahead and click on run again. So it's very integrated. Again, there's my new body of where the mesh is going to be. That's awesome. And then I go ahead and click on run again. And then again, while it's running, I can go back to that section plot and just refresh those numbers, because numbers are from the old one. Just hit refresh, and now we have some new velocities. And that's going to go ahead and converge and give us a solution. So that's how easy it is to run a ball valve inside of Creo Flow Analysis. Hope that makes a little sense. So let's close that and hit no, I don't want to save it. Let's bring up another one here. Let's do a heat conjugate problem. In this case, we have 3 components. We have a base plate, we have a heat sink right there, and we have the flow analysis, the air up on top. Okay, so if I just kind of hide that part, we're just going to run some air over this heat sink. Okay, I want to show you how simple this is. It's actually very, very simple to do. In this case, I made the fluid component before I went into CFD. So I go to flow analysis, I hit new project. So first I have to just throw in my different items I want to solve on. Okay. And again, if anybody has questions as well while I'm doing this, please type them into the queue. If anything prompts you, go ahead and type them in there. And then I'm going to go ahead and add I'm going to say select my simulation domains this time, because last time I created them, this time I'll select them. So for fluid, I'm just going to pick this component right there. And for the solid components, it picks the other ones that makes them available. And I have the sink final and the base plate. Okay, so that makes sense. That's all done. And I do want to have a couple of new boundary conditions. So I go to here, my fluid, and I say add a boundary condition right there. That gets added right there. Okay. We also want to add one to the end there. So now we have the front and we have the back. So the front there, let's just say that's going to be our specified velocity again. You can do velocity, you can do pressures. And then I'm going to say again, let's just say 2 meters per second again. And then we're going to hit OK. And then let's go to boundary condition 2. And let's go ahead and just say that's going to be our outlet. And good. So I think I have to add in streamlines. That's what I forgot to do. Notice that when I forgot to add streamlines, so I'm going to add streamline over there. Now watch what happens is, now boundary condition 1, now I get that available option for releasing particles. I didn't have that before. Okay, so now I have that. Good, so everything else is done. Good, so now what I want to do is I want to click on the mesh button. Now notice here, there's a thing called interface. This is really key, is that the interface is empty right now. Once I hit generate mesh, the interface will populate and tell me all the different areas where my components are touching. Okay, and that's a nice component to this, because then I can go ahead and apply conditions between those interfaces, like a convection coefficient, or in this case, it's a heat conjugate problem. there's my interfaces. So the base plate to the sink is right there. That's awesome. It actually found all those surfaces that it has in common. And it understands it's a heat conjugate wall. And I'm gonna say, let's add a heat source of maybe like 20 watts, okay? And that's all I have to do. I could add some other conditions here, but I'm just gonna say run at this point. And then while it's running, I can go ahead and look at streamlines here. And I can say, let's look at temperature. And I see the numbers, but I don't see anything here. I think I have to click on release particles. Yes, I must have missed that. Okay. Now I go to streamlines and I see some streamlines. Okay. So there's my streamlines going across there. I can see my temperature changes between 300 degrees, which is the start of all my components and the start of the fluid, and it goes up to 360 near the heatsink. Okay, so a good example to look at here is I'll go to my section view again. I get a section now, and then I can look at the Y plane. Let's go down into the model a little bit, and then let's look at temperature. And there's our little plume of air as it goes from 300 degrees here, hits the heatsink, and then we have some heated air behind it. And then we can do all kinds of stuff with animation and things like that. But that's the main thing I wanted to show you here with this example.
All right, thank you so much for showing that. I do actually see one question that's coming into the queue. Is Creo Flow something that PTC developed, or is it some type of partnership?
It's actually a partnership, yeah. I think I have a slide on that. Yeah, so the company behind the technology is called Cimerix. This is a partnership that PTC had with them. So they are founded in 2006. They're out of Bellevue, Washington, and they're just a lot of scientists and engineers. And they developed this technology, and then they partnered with PTC just a few months ago, or actually, I guess almost a year ago, for Creo 5.0. So the two examples I did were just both internal examples. I also have one more. I'll show one more as well. It's an external one of a drone. Okay, just want to show one more here. This is a pretty simple one. We have this assembly. We'll just go ahead and simply say flow analysis and a new project here. Okay, so one thing you have to do here is I just have to simply say, let's go ahead and go to our fluid domain. And I don't want to actually create one. I want to select, that's right. I'll say, just go ahead and say select, go to my model tree and grab all of them here, like that. And let's go over here and get rid of this one. Yeah, okay. So notice I can go back and forth between Creo and flow analysis. There's our domains, and this time we're going to do an external. So we're going to say, let's just do our external volumes like that. And it's going to make a box. We can review that. It's going to, we can add and remove different spaces between the mesh, but that looks good. Let's just simply say generate a mesh. And I think that's my last step here. And then I have to just tell it a couple things. So since I hit generate mesh, it's going to create my boundary conditions for me then. And then I can add the walls and give it, I think I want to add like a 600 miles per hour wind on our drone, and then give it some more definition on the other walls that are here as well. So this is a larger assembly. Notice it's just going to create all the cells now. It's up to 283,000. It's got many thousand faces and 638,000 cells. Okay. So the last step here is to go ahead and pick on my walls here. So this wall in the front is going to be our first wall we're going to define. So first we got to add some physics here, just a fluid and streamline. And then we go to that same thing, the direction max. And we're going to say that's going to be a specified velocity. And for the velocity, actually, let's do in the Z direction, I believe is what I want. 268. Hope that's right. I think that's, I didn't write that on my notes here, so I think that's right. And then for the other walls, other 5 walls, we're going to say that's going to be an outlet pressure. And we're going to say the Z value will be the minus 268 for that one. Okay. And we want to release those particles, I believe. Yes to that one. I forgot to pick yes here. And also we want to look at pressures on the actual walls of our wings. So we'll pick on those, and then also the nose here. And we're going to say release particles there. That just gives us the ability, it calculates those values on those different sections. And we're going to say both for that one. All right, so then we just simply say run. And now while it's solving, I can go back, I can go down to my results area here, and I can pick on the streamline, and I can see different values here. Let's go look at just pressure. I think I did something wrong. Yeah, I think I did something wrong there. Let's go to our, oh, it's just converging. Okay, it looks better now. Okay, I was just too fast in looking at results. We can change this line thickness here to a little smaller, and give also here our 0.00015. We can look at those. We can also look at the wings. So the wings here and the nose, we can turn those on in the results area. Where's nose? And then we can say, let's go ahead and look at pressure there. Okay, so still converging, give me results, but that's kind of that's also a wind tunnel example that you can do. You can do that with any kind of type of structure you have that's in the wing, in the wind. In addition to doing this, there's also many other capabilities that we have here that you can do with Creo Flow Analysis. So that's my last example, Jess. So is there any other questions or anything else you wanted to cover today?
I'm not seeing any other questions in the queue. Just as Todd said before, if you do want us to show you a personalized demo, we definitely have the ability to do that. We want to thank everyone for joining us today on the webinar. We appreciate the time that you took to be with us this afternoon. We hope to see you on future EAC webinars, and have a great rest.